This video is on average rate of change. And you've probably heard about this before. You know, we covered it when we talked about slope, because really average rate of change between 2 points is the slope. So I'm going to give you a definition. If you know the slope definition, though, you kind of already know this, right? So for this definition, the average rate of change between 2 points, which I'll call x1, y1, and x2, y2, is, and it's really this formula, right? So average rate of change is equal to the change in y, so y2 minus y1 over x2 minus x1. It's the slope formula. It's a slope between 2 points, change in y over change in x. Remember, you have to be consistent with your order here. If you start here and subtract the y here, you have to start from x here and subtract the x here. I'm just going to write it just explicitly in case you didn't hear me say it. Note this is same as the slope, right? So this is the same as the slope. So when we go to use this, they might not say find the slope. Really, a lot of the problems you'll see will say find the average rate of change. Sometimes they'll only give you the x value, you have to find the y value, but then you find those coordinates and you actually go through and evaluate. So for this example here, if I said for f of x equals x squared, find the average rate of change as, and we'll do just a couple just to make sure you see it. So for the first one, find the average rate of change as x changes from 2 to 5. Now remember, these are x values that are 2 and 5. The whole formula is based on the fact that we have, you know, 2 different points, x1, y1, and x2, y2. So to find the y coordinate that goes along with each of these, you want to substitute them in for x into our function and then evaluate to find the y value. So I need f of 2, which is really the y value at 2. Sometimes you might see this formula even written, you know, with f of b minus f of a over b minus a. It means the same thing. So for f of 2, we're looking at 2 squared, just subbing in for x, so that equals 4. So that tells me that the point 2 comma 4, x comma y, right, is a point that I'm using. And the other point we're looking for, f of 5. We know x value is 5, the y value would be whatever 5 squared is, substituting into the function. 5 squared is 25, so the point that comes from this would be 5 comma 25. Now I didn't answer the question, right? The question was find the average rate of change, which really means find the slope, right? Remember, we use the letter m for slope. And if I'm talking about y2 minus y1, I can do 25 minus 4 over x2 minus x1 would be 5 minus 2. This ends up equaling 25 minus 4 is 21 over 5 minus 2 is 3. 21 over 3, well, that equals 7. So the average rate of change here, right, is going to be 7. It's really the change of y, right, over change in x. Right? So it's the average rate, though. It doesn't mean that every point it goes up by 7. It just means on average between 2 and 5, the y value is increased by 7 for every one change in x. But it doesn't mean it's definitely that, right? It's really just the average of the change. What if we looked at this one here? So same function, but the average rate of change is x changes from -3 to 1. And it's the same thing, right? It's really asking us to do the same thing. The x values are negative 3 and 1 now. We have to find the corresponding y values. So if I said f of negative 3, make sure you understand that it's negative 3, the quantity squared when you replace x here. So make sure you have parentheses. It'll change your answer if you don't. Negative 3 squared gives you positive 9. So we know one of the points we have is negative 3 comma 9, right? X comma y. The other point for f of 1 is equal to, subbing in 1 for x, so it'll be 1 squared. And 1 squared is just 1. So the other point we have is 1 comma 1. These parentheses you didn't need because it was a positive base. This one you did need the parentheses because the negative 3 was the base. So again, finding the average rate of change means find the slope. Change in y, maybe I'll do it this way, 9 minus 1. Now if I start here and subtract here, then when I do the change in x, I have to start with the same point. So negative 3 minus 1. 9 minus 1 will give us 8. Negative 3 minus 1, that's going to be a negative 4. And then 8 divided by negative 4, well, that equals negative 2. So in this case, the average rate was negative. In this case, the average rate was positive. This is a negative slope. This is a positive slope. Remember, this is the average rate of change. It's not the exact rate of change between points. It's the average between them. Let's look at an application of this. So, for this example here, suppose I gave you a table, alright, so the table below, and I'll give you the table in just a second, compares the number of items produced to the time of day. Right, so this is for a company. And the time here, which maybe I'll label this as, right, times in hours. We have 1, 2, 3, 4, and 5. And then here we'll say this is the number of items produced. Right, so that's what I wanted this to be. I'm giving you this information. You wouldn't come up with this on your own. I'm telling you at 1, there were 15 number of items produced. At 2, 38. At 3, 42. At 4, 44. And at 5, 60. Right, so that's a table giving you some information. Let's use it to answer some questions that go along with it. So, first question, we'll say determine the average rate of change. Remember, average rate of change, when you hear it, means slope. You should think that to yourself. The average rate of change between hours 1 and 4. So they're telling you the x values in a sense, and you can think of the time as the x values, and the y values are the number of items produced. So if I'm looking for the average rate of change, really, I know the x value of 1 has a y value of 15. The x value of 4 has a y value of 44. So I'm trying to find the average rate of change here between the hours of 1 and 4. I'm really using the slope between 1 and 4. The change in y over the change in x. Well, at 4 it was 44. So that's the y value minus the y value at time 1. So 44 minus 15 over, remember, if you started here and subtracted this way, you have to start here and subtract this way. So 4 minus 1, right? So at 4 hours, 44 items were produced. At 1 hour, 15 were produced. This is like a point x comma y. So 1 comma 15, 4 comma 44. And we're using this to evaluate. 44 minus 15 gives us 29. Over 4 minus 1 is 3. And 29/3 doesn't reduce, but because we want to look at this in terms of an application, we should take a look at what 29 divided by 3 comes out to. And I get 9.6 repeating. We'll approximate it, I'll say to 2 decimal places. Typically I'll tell you what I want you to approximate to on an assignment, but we'll say 2 decimal places. So 9.6 repeating makes us 9.67. All right, and then what are the units on this? Well, it's the change in y over change in x. The y values were in items per the change in x is time, which was in hours. So 9.67 items per, really let's just say per hour. All right, so approximately 9.6 items per hour is the change in the items produced between 1 and 4 hours. And maybe we'll write this out just so you have it in a sentence, right? So between hours 1 and 4, the rate, right, or the average rate increased, right? It's a positive number. You should say this word increased. If it was negative, you'd say decreased. So increased by 9.67 items per hour. All right, so it gives you information. Being a positive number tells you the number of items was increasing at a rate of 9.67 items per hour. What it isn't saying is that every hour it increased by 9.67. We actually can see in our table that it didn't increase by exactly that, right? After the first hour, it went up by 23, but the second hour it only went from 2 to 3 up by 4. On the third hour it only went up by 2. But remember, on average, right, the average rate, it increased by 9.67 items per hour. We'll look at one more using this table. I'll call this part B. We'll say determine the average rate of change between hours 3 and 5. All right, so determine the average rate of change between hours 3 and 5. Again, you see average rate of change, and you should be thinking to yourself slope. And, you know, looking at the slope between hours 3 and 5, well, at hour 5, the items produced was 60, so that'll be my first y value. So 60 minus, at hour 3, the y value there is 42, so we got 60 minus 42. All right, so y2 minus y1 over, remember, x2 minus x1 would be 5 minus 3. And evaluating that, 60 minus 42 gives us 18, over 5 minus 3, which is 2, so this equals 9. And that's 9. Make sure you put units. Units of y are items, all right, over units of x, right? Those were in hours, so 9 items per hour would be the rate of change. Now, it's positive. Positive tells you it's increasing, right? So a sentence to go along with this, you could say between hours 3 and 5, the average rate increased by 9 items per hour. So it's important to understand what you're finding. Also important to know that, you know, depending on what the values are, you could get different average rates, right? So make sure you're answering what the question's asking. You're not picking those randomly. All right, so this example here. We'll say the amount invested into an account T years after the initial investment is given by, let's call it A of t is the function name. It's equal to 2000 times 1.015 raised to the 4t power. So we're giving you this, right? So I didn't give you any other information. You might understand where this formula comes from, what the pieces mean from what we've talked about at different parts of the course, but doesn't really matter at this point. Just make sure that's just given to you. Part A, say find A of 3 and A of 5. It's just asking me to find these. Remember what this means. A of 3 means when you put t in as 3, right, you're substituting t as 3 over here. So we would have A of 3 is equal to, we're going to see a t, you're going to put in 3 now. So it would be 2000 times 1.015 to the 4 times 3 power, which really is the same as saying 2000 to the 1 point, or times 1.015 to the 12th power. And evaluating this, you should evaluate it on your calculator. If you evaluate this on your calculator, you got 2000 and then in parentheses 1.015, close parentheses, raise that part in the parentheses to the 12th power. We get 2,391.236. Remember, this is money, so I'm going to raise that up to 0.24. So this is going to be equal to 2,391.24. This is dollars, remember. So A of 3 is, right, after 3 years, there's $2,391.24 in the account. In a similar way, we can find A of 5. A of 5 is equal to 2,000 times 1.015 to the 4 times 5 power. I think you understand where I'm getting at just by putting 20 there. And then multiplying this, 2,000 to the 1.015 to the 20th power. And you end up with, this comes out to 2,693.710, so 0.71. And this again is in dollars. After 5 years, there's $2,693.71 in the account. Part B, we'll have to find this, A of 5 minus A of 3. Well, this isn't challenging. It shouldn't be, right? A of 5 you just found was a 2693.71. Alright, so 2693.71 minus A of 3 was the 2391.24. And that should be equal to, well, if you subtract those, 2693.71 minus 2391.24, I get 302.47. Now, the units on this, remember, these units were in dollars, so the difference should be in dollars. So $302.47. What does that mean practically, though? Well, this is telling you this was, what, the money from year 3 to year 5. So it's the money that you gained, right? How much did it go up by between year 3 and year 5? So this was the money gained between years 3 and 5. I think that's what that really shows. And lastly, if we ask you to find A of 5 minus A of 3 divided by 5 minus 3, right? So you're just asking us to evaluate that. Well, you already have pieces of this, right? The A of 5 minus A of 3 we just did, right? That's the 302.47. 0.47 over 5 minus 3. Well, that's 2, so this equals, and if you evaluate this, 302.47 divided by 2 is equal to 151.235, so I'll round it up to 4, so 0.24. And then think about what the units are on this. And it's really identifying what this is telling you about. A of 5 minus A of 3, that was in dollars, right? We know that from up here. The 5 minus 3 actually represents the x values, right? Or the t values in this case, which were years. So this is dollars, right, per year. So what's really saying is that, if you notice this is the average rate of change. It's the slope formula. It's the change in y over the change in x, right? The change in the amount over the change in years. So what it's really saying is that the average rate of change, right, between year 3 and year 5 is a positive 151.24 per year. Positive means increased by, right? So a sentence that could go along with this, and there's other ways to phrase a sentence, but make sure you're talking about these key parts of it. The amount in the account increased by an average rate of change, or I shouldn't say an average rate of change, an average rate of $151.24 per year between years 3 and 5, right? So the amount in the account increased by an average rate of $151.24 per year between the years 3 and 5. So it's an application of average rate of change. The key to these questions, though, is understanding what this formula is showing you. Sometimes they'll ask you this, and people can do the calculations, but they don't understand what it means in application form in terms of, you know, this is a slope formula. It's really telling you the average rate of change between the time frame of those t values, or x values in most cases. So hopefully this helped, you know, give you applications of slope. As we go on, we'll talk more about how we use the difference quotient as the derivative and find the instantaneous rate of change rather than the average rate of change.